Let's learn about this paper, Reinforcement Learning with Verifiable Meta Reasoning Rewards for Robust Long Horizon Agents by Hunyuan, AI Digital Human Tencent. So I will use this Notebook LM new feature video generation with it will explain this paper with a video, and I'm using this for the second time. So in the future I will improve this video generation and um, create it or edit it myself, so it's really good. But let's see what it looks like.
Into a new research paper that is genuinely exciting. It proposes a way to build AI that doesn't just chase a goal, but actually understands the process of getting there. We're talking about teaching AI how to think, not just what to do. So let's get right into it.
So let me start with this question for you. What if an AI gets the right answer, but for completely the wrong reasons? It's like it stumbled onto the solution by pure luck. If we don't know how it got there, can we ever really, trust it to do it again?
So the point in AI, what we need to do now is we need to deal with the situations where wrong reasoning steps lead to correct answers. So we are rewarding entire reasoning chain, but those are wrong reasoning steps that will hurt us later if we reward them. So we need to deal with that.
This is a huge, huge problem in AI right now. And this leads us to what you could call a hidden flaw in a lot of today's AI. The researchers behind this paper have a name for it: inefficient exploration. And it's a pretty fundamental weakness in how these systems actually learn. Okay, here's the perfect analogy. Think of a student who just aces a really hard math test, but turns out they didn't actually learn the formulas. They just got incredibly lucky guessing on all the multiple choice questions. So yeah, they got the A plus, but did they really learn anything? Are they going to be able to solve the next problem? Nope. And that's exactly what's happening with a lot of AI today. So here's the more official definition. When an AI gets lucky and finds a solution, its programming just reinforces that whole sequence of actions, even the nonsensical parts. It basically learns a weird, lucky ritual instead of a solid strategy. And this makes the AI what we call brittle. The second you change the problem just a tiny bit, the whole thing shatters.
The authors of the paper really nail it with this quote: "The AI learns how to find solutions, sure, but it never learns how to reason. So we can't take what it's learned and apply it somewhere new." So the big question is, how do we fix this? How do we teach an AI to not just pass the test, but to actually, show its work?
Well, the solution these researchers came up with is a really radical shift in how we think about this. It's simple but powerful. Instead of just rewarding the final destination, we need to start rewarding the entire journey. This slide just lays it out so clearly. The old way, you only get points for the final answer. End of story. But this new way, the RLVMR way, it's completely different. It's like that teacher who gives you partial credit for showing your work and using the right method, even if you messed up the final number. It gives the AI points for thinking things through, step by step.
Now, the key skill we're trying to build here is something called meta reasoning. It sounds kind of complicated, I know, but don't let the word fool you. It just means the AI can think about its own thinking. It's the ability for the AI to have this little internal monologue to say, okay, I'm planning my next steps now, or, that didn't work out. I should probably rethink my approach.
Okay, but how in the world do you actually do that, right? How do you give an AI points for good thinking? Well, this is where the paper's actual framework comes in. Let's take a look at how it works. It's called RLVMR. And yeah, it's a mouthful. It stands for Reinforcement Learning with Verifiable Meta Reasoning Rewards. But the name actually tells you exactly what it does. It's a system for giving an AI rewards based on a thought process that we can actually see and verify. So here's the simple breakdown. First, the AI just does something in its world. But then, and this is the brilliant part, it has to label what it just did with a thought tag. It has to say, I am now exploring, or I am now planning. Third,
AI explicitly tags its own cognitive steps like planning.
a set of pre-programmed rules sees those tags and gives out little rewards for smart moves, like exploring a new place instead of going back to the same old one. And over time,
all these little process rewards add up, guiding the AI toward a much, much smarter way of solving problems. Now, this all sounds great on paper, fantastic in theory, but does it actually work in practice? Does rewarding the process really make a difference? The researchers put this thing through some seriously tough tests to find out.
And we're not talking about simple video games here. They used benchmarks like Science World and Alf World, which are these incredibly complex virtual environments. They require the AI to understand language and perform long, multi-step tasks, kind of like following a complex recipe or running a lab experiment. These things need real planning and logic, and the results were absolutely staggering. I mean, just look at this chart. On the hardest tasks that the AI had never seen before, the old methods were topping out around 65% success. The RLVMR model, it shot up to an incredible 83.6%. That is not just a little bump, that's a massive leap.
Let's just focus on that number for a second. 83.6%. This isn't just a win, it's a new state-of-the-art result. It's basically proof that teaching an AI how to think is way more effective than just teaching it what to achieve.
So how did it pull this off? Well, when they looked under the hood, the RLVMR agent was just plain smarter. It cut way down on stupid, redundant actions, like checking the same box twice. It got way better at realizing it made a mistake and then recovering from it. The bottom line is, the quality of its actual reasoning was just on another level.
I get the vibes of constitutional AI by Anthropic here, where I think they reward based on like these LLM descriptions, but this is really good LLM descriptions to reward like the reinforcement learning. Maybe good for some, but needs to be combined with other like verifiable results maybe.
Okay, so let's zoom out for a minute. A new high score on a test is great for the researchers, but what does this actually mean for the rest of us? Why is this such a big deal? The impact really comes down to these three things. First, we get more robust agents, AI that doesn't just fall apart when it sees something new. Second, we get more efficient agents that don't waste time on silly mistakes. And third, and this might be the most important one, we get more interpretable agents. Because the AI is literally telling us its thought process, we can finally look inside and actually understand why it's making the decisions it's making. And that is the key that unlocks everything else. This is way more than just an academic paper. It's a foundational step towards building AI that we can really, truly trust with important, high-stakes jobs. We're talking about the AI we need for self-driving cars, for helpful robots in our homes, and for tackling the biggest scientific challenges out there. So I'll leave you with this final thought to chew on. For so long, we've been obsessed with the answers an AI can give us. But maybe this research shows we should have been focusing on its process all along. If we can really teach an AI how to reason, just think about the incredibly complex problems that we could finally trust it to solve. And that's the explainer.
Okay, I like this. I think it should have gone into more technical detail. It didn't explain too much technical detail. I think it was too simplistic. So I'll see what I can do about this. If I get any control here, or maybe we can, maybe we cannot use this in the future. I'll see. So thank you for watching and see you next time.